Business analytics has evolved from being a number crunching tool for decision making to an important vertical because of its power to impact the profitability of an organization. In the 21st century, it has emerged to become an important differentiator between high performing and low performing companies. This presentation will help you understand the different types of analytics, such as descriptive, predictive, and prescriptive analytics, the tools and techniques used in analytics, the roadmap to building an analytics-driven organization, and the steps for implementation of business analytics in your organization. Analytics can be used at different levels for process improvement, for problem solving, for decision making, and as a comparative strategy. Many successful companies use analytics as a standard management practice. The deployment of an effective data-driven decision-making program is unavoidable, given the scale and complexity of today's business organizations. The data analytics market is expected to grow very fast. There is not enough manpower available to cater even to the existing demand. The need of the hour is to train experienced executives who understand the business context in the use of the tools and techniques of analytics to cater to the demand-supply gap. Every company monitors its key performance indicators. That is not good enough. They need to have a good understanding of the factors that influence the KPIs. These factors are not always apparent or intuitive. The key to success is discovering the influencing factors and building them into the analytics model to better understand their influence on business outcomes. As I said earlier, improving KPIs needs action, and actionability depends on having a good understanding of influencing factors and how these relate to the KPIs we are trying to improve. The primary components of data analytics are quantitative methods, artificial intelligence, data management, and computing infrastructure. It is possible to start with a few introductory steps which do not require all the components to be in place and can be accomplished relatively easily. Descriptive analytics with data visualization could be a good first step. Amazon was one of the early adopters of analytics, driven by its scale and complexity of operations. Amazon ships approximately 1.6 million packages per day. Amazon uses data analytics to forecast demand, predict order cancellations by customer, detect fraudulent transactions, estimate delivery time and cost, and predict customer interest in other products. Key business decisions depend on this knowledge, and decisions are programmed around the predictions made by the analytics sans any human intervention. Implementing analytics obviously requires knowledge of the tools of data science and an ability to interpret the results. More importantly, the business context needs to be understood by the analytics team to understand the dependence relationships between variables. Technology plays a key role in the use of the tools and in collection, storage, retrieval, and presentation of data. Descriptive analytics is a primary analytics type used to describe data to derive insights that may not be apparent. The insights can be used to take corrective action. Visual dashboards are created for different levels and functions that report data in real time to enable quick response. Data is generally understood to be numerical data organized in matrix forms, in rows and columns. But data is also generated in the form of text, images, videos, voice, sentiment, click streams, and actions of people. These are equally meaningful. If we want to know something about our operations, we can collect data on everything that happened, called the population, or a subset or sample of it in a scientific way so that the sample permits us to draw correct inferences about the entire working or the population. Different sampling techniques are used based on need for accuracy balanced with willingness to make time and cost commitments. Population parameters can be estimated using sampling techniques. Confidence intervals tell us the range in which the population parameter will fall with different levels of confidence or probability. Data is analyzed using several statistical measures, each of which interprets data in different ways, providing meaningful insights into the working. Some of the important statistical measures may be categorized as measures of central tendency, measures of variation, and measures of shape. The distribution of data is used to gain insights. The distribution can be actual distribution or probabilistic distribution. The distribution of data commonly used in statistical computations are binomial, Poisson, exponential, normal, and chi-square distribution. A hypothesis is a claim or an assumption made while making a business decision. An incorrect assumption will lead to wrong decisions. The assumption needs to be tested for correctness at a high level of probability. Two opposing assumptions, the null hypothesis and the alternate hypothesis, are made, and the sample data is used to reject one or the other at given levels of confidence or probability. Visual analytics is a powerful tool used in descriptive analytics. It is not about creating visually appealing dashboards or about seeing several data elements in a single dashboard. Visual analytics enables creation of dashboards that are interactive. Dashboard 1 shows sales volumes of all products by country and sales volume of each product across countries. In the dashboard 2, one country, Australia, is selected. The sales volume of each product in Australia can be seen. In dashboard 3, one product, eclairs, is selected. The sales volume of eclairs in each country can be seen. Dashboard 4 shows sales of all products by month. Dashboard 5 shows changes in sales by product from January to February. The dashboards help you drill down and see details of different business variables. The first stage of deployment of analytics is the identification of an opportunity area that will yield the greatest returns. We need to identify an area for operation which, if improved, is likely to significantly improve performance. This area of opportunity is then examined in depth using the tools of data analytics through sampling and other techniques. Apart from descriptive analytics, predictive analytics is the most frequently used type of analytics across industries. The use of predictive analytics can reveal relationships that were previously unknown and are not intuitive. Predictive analytics can assess which product will be a hit, which product a customer will need, which employee will perform or will leave, which customer will be the most profitable over time, what will be the competitive price scenario in the forthcoming period. Predictive analytics helps us predict future occurrences based on an assessment of influencing variables and how these have led to certain outcomes in the past. If the influencer variables are known from historical data, the future can be predicted. Predictions can be made on demand for a product, customer churn, employee attrition, insurance claims, price of materials, to name a few examples. Here is an interesting real-world application of HR analytics that influenced business results significantly. Sports clubs select players based on proven record of success. Once the success is proven, the price of the player goes up. Oakland Athletics identified success factors and predicted success for talented players who had yet to establish a record and were consequently reasonably priced. The cost of acquiring players was controlled by the use of this prediction model. Corporates can also use prediction models to select the right employees. Prescriptive analytics is the third major field of analytics. Prescriptive analytics tells us what we need to do to maximize or optimize outcomes. It helps us to choose from several alternatives, and the choices are not always obvious. The discipline of operations research has several optimization algorithms which can be deployed to arrive at optimized functioning. To sum up, descriptive analytics tells you what is happening. For example, which customers are buying our products. Predictive analytics tells us which customers will buy our products, which ones, in what quantity, and when. Prescriptive analytics tells us what combination of products and customers will yield the best results. Some of the more commonly used predictive analytic tools are mentioned in this slide. Of these, the more commonly used ones are correlation analysis, simple linear regression, multiple linear regression, logistic regression, forecasting, and Markov chains. The prescriptive analytics tools are mentioned in this slide. The commonly used algorithms are linear programming, integer programming, and multiple criteria decision making. Correlation analysis tells us how two random variables are associated. Correlation indicates association but does not necessarily indicate causality. Understanding of correlation between features helps us take informed decisions. Simple linear regression is a model that works with one independent variable x and one dependent variable y. The relationship between the two is defined by the value alpha called the intercept and the value beta called slope. The model is simplistic because dependent variables such as demand are a function of multiple independent variables such as price, distribution, promotion, competitive activity, and other environmental conditions. Also, the relationship may not be linear. Multiple linear regression is a model that works with one dependent variable y and several independent variables x1, x2, x3, etc. The relationship is defined by the intercept alpha and coefficients b1, b2, b3, etc. Here, dependent variable y could be demand and independent variables x1, x2, x3, and x4 could be price, distribution, promotion, and competitive activity. When the dependent variable is binary, which means yes or no, with one or more independent variables influencing it, logistic regression is used. The outcome is expressed as a conditional probability. Forecasting is a very popular requirement of analytics, and several tools can be used for forecasting, such as time series analysis, regression analysis, exponential smoothing, moving average, seasonal decomposition, Monte Carlo simulation, and judgmental forecasting. Markov chain is a tool that uses a set of occurrences in the previous period to predict the occurrence in the next period. The value of the occurrence in the next period is predicted with conditional probability. The variables could be market share, condition of assets, stock prices, number of waiting customers, etc. So if the value of the variables for n previous periods is known, the value of the variable in the n plus first period can be predicted with conditional probability. Markov chain has been used to predict the credit rating of a company, movement of stock prices, condition of machinery, consumer behavior, market shares, non-performing asset volumes for banks, consumer sentiment, and investor likelihood of buying and selling shares. Linear programming is an optimization model comprising of an objective function, which is typically something you want to maximize, such as profit and productivity, or minimize, such as cost and time. The goal is achieved by varying factors that can be controlled by us, such as production volumes, manpower deployment, resource commitments, etc. The decisions are moderated by defined constraints. The objective function is typically a sigma or summation of the variable x times coefficient c. If the objective function is a profit maximization function, the coefficient c could be profit per unit of sales times number of units of the product x sold. The algorithm will give values of sales volumes of the company's products x1, x2, x3, x4, etc. in order to maximize profit subject to applicable constraints. There is reason to believe that we have produced more data in the last 10 years than we have produced in all of mankind's recorded history. Data is being generated at an astonishing pace. A telephone company generates terabytes of data from call records every day. A jet engine creates data on temperature, RPM, fuel consumption, and emission from its sensors every 10 seconds. Such data is referred to as big data, which could run into petabytes and exabytes. Big data is characterized by volume, velocity, variety, and veracity. The process of data-driven decision making must follow a sequence in order to be effective. Typically, we may start with identification of an opportunity to improve, say manpower attrition or productivity. The relevant data that is likely to influence the outcome must be identified. The data must be processed to ensure accuracy, completeness, and continuity. Sometimes derived variables are created, such as cost of acquiring one customer. The data must be split into data for training at the model building stage and data for validation of the model. Sometimes several models are developed to arrive at the model that works best and returns the best results. And finally, the solutions are implemented on the ground. Analytics requires commitment and effort, and it is necessary to build a roadmap for adoption. The stages of adoption are defining the analytics strategy, building talent, building infrastructure, identifying sources of data and collecting data, and finally preparing a plan for implementation, which includes organizing, staffing, coordinating, and controlling. The strategy must define in which areas analytics will be introduced in the short, medium, and long terms. The key stakeholders must be identified and inducted into the plan with appropriate levels of training and exposure. The output expectations from each stakeholder need to be spelled out. The skills required are of a high order. People must be trained and fresh talent hired. Some key functions may be outsourced. The business context assessment must be done by experienced in-house executives. The program must be led by a core group of people with functional experience. The software required must be acquired, though a lot of it is open source software. Hardware infrastructure is needed for the collection, storage, and retrieval of data. The data is the critical element of the program, and all efforts must be made to achieve data integrity and continuity. Implementation must start with small improvements. The high opportunity areas must be identified. Communication to all stakeholders must be made and their buy-in obtained. The cost of the program must be assessed and the potential gains estimated. The greater the opportunity for improvement, the higher would be the returns. The implementation can start once the preparations have been made as defined earlier. The implementation stages are opportunity identification, collection of relevant data, data pre-processing, analytics model building, and model deployment. Identification of an opportunity for improvement is the first implementation step. It helps focus on areas that promise the highest returns. The areas could be market share of a product, sales within a geography, efficiency of a manufacturing unit, manpower attrition in a specific area, supply chain challenges in a region, vendor performance for a material group. It is important to understand the association between the variable we are trying to improve, say sales, and independent variables which are associated with or have a causal relationship with the variable. The data collected must be cleaned, complete, and correct. Improper data will lead to incorrect inferences and decisions. Model building needs a deep understanding of the business context as well as the functioning of the model. Experienced managers must be trained in analytics tools to give them a good understanding of the logic of using certain tools and how results need to be interpreted. A case of not incorporating the right features is the tragic failure of the Challenger mission in 1986. The analytics team reviewed the data and concluded that temperature was not conclusive in predicting O-ring failure, the cause of the disaster. The dataset excluded instances of success and the relationship with temperature. Post the failure, a reassessment was made by including data on successful launches and temperature. The conclusion was that O-ring failure correlated with temperature. The temperature at the time of the failed Challenger launch was 36 degrees Fahrenheit, a condition that made failure inevitable. Finally, the solution must be deployable. The recommendations must be carefully assessed by deployment on validation datasets and also by the application of judgment. It is desirable to try out deployment on a test scale and observe results before a full rollout. Thank you for your patience. I hope the presentation gave you an understanding of the concepts, tools, and implementation roadmap for business analytics in your organization.